Hello and welcome back to Chris's Granite Paradise. Today we're talking about Montana agates found in the Yellowstone River. So first of all, what are we talking about when we say agate? Agate is a very broad term, and in the case of Montana agates, they can be really quite a variety of colors and patterns, but the most common, I would say, are what I call blue or a grayish color, such as this one here. This is a large piece that my wife found in the Yellowstone years ago, and I cut and polished a portion of it. Then another, probably the most common, are what I call honey agates. I'm not sure if that's an official term or not, but they're more of a yellow color, maybe even a rust color. Beautiful pieces. But I think what most people look for are what I call the dark ones. I'm not sure what the correct term would be. You can kind of see the light going through there maybe. But they're a darker color. They tend to have inclusions. I think that's showing. This one just has a few inclusions, but those are the most desirable, I think, in terms of jewelry, are the ones with the dendrites, usually iron or manganese, producing beautiful patterns within the agates. Then, of course, a lot of them are filled with druzy quartz, which in a river rounded version looks like this. You can kind of see the crystal structure. Agate around the outside. So I'm going to assume that if you're watching this video, you've probably looked for agates and are somewhat familiar, but I'm going to go over a few things that I have found very helpful. But basically, agates on the Yellowstone River, I read yesterday one person described how they were talking about how they describe them, and they just say they look like potatoes, and I thought that was a fascinating description. Because honestly, most of them are quite ugly, especially the big ones. So if you look at these, there really isn't much to attract us to them. So I agree with that. They kind of look like potatoes. And but so how do we know they're an agate then? So this is a good example here. So the outside of the rock kind of looks like this. But you look for these shiny conchoidal fractures is one way. And we could say that that's a waxy look and waxy feel. And then this one, of course, is cut. See, the light goes through it quite nicely. Even got a little bit of dendrite activity going on in there. So it's, in this case, mostly clear agate inside, but the outside is that potato look. And the reason it has that look, other than in the protected areas where rocks really can't smash against it as it's rolling down the river, those maintain kind of a more polished, waxy appearance. We call those windows. And any of these bigger ones, so the way they were found, you can see this has little windows as well. They're kind of shiny, waxy looking, and show hints of the agate inside. So we mentioned that one thing to look for when looking for agates are these rocks that look like potatoes, and they have the little areas that are protected from the shattering of other rocks in the river, and they look waxy. We call those windows. But another way we could find agates is if the sun is at a low angle. Of course, you can see the light shining through them, such as these. Especially, I sprayed these down with water just to brighten them up a little bit. But that's another key way to at least find the more clear agates. This method probably won't help you find the dark ones, but at least the clear ones you can find this way. Now, if you're up away from the river, because remember, the Yellowstone volcanic field, if we can call it that, or that whole area of volcanism has been eroding for, I mean, at least 600,000 years ago when the Yellowstone volcano is believed to have gone off, but even before that. So this petrified wood and these agates have been coming down not only the current Yellowstone River, but ancestral rivers as well that maybe don't exist anymore, but they've left these huge gravel deposits high and dry all throughout the Yellowstone Valley. We talked in the video that I did recently on the Yellowstone River, So Much More Than Agates. I talked about the paleo landscapes and these gravel deposits that are no longer near the river at all, but they're high and dry. But those are still full of agates because this material has been washing down for so long. And when you go in these high dry areas, the agates that have been sitting in the sun exposed for obviously a long time, they develop this white patina on them. And so basically the rocks look really white. But you can find evidence of the banding. I had one here that really shows the banding quite well. So if you look on the outside here, it looks like it's a nice banded agate, but inside it's just a regular Montana agate, and it shows some signs of the banding, but for some reason the patina tends to really accentuate it, which is kind of nice. The other thing to note about these, the druzy quartz does not develop the patina. So often you'll find where the agate is white, but the quartz is unchanged. This little specimen clearly shows how the agate, because of its cryptocrystalline properties, over a long time reacts with the sunlight. This doesn't happen like in our lifetime. But it reacts with the sunlight and the weathering and develops the patina, even a shine, whereas the quartz does not. You can see here's druzy quartz where the agate was filled with quartz, and there's no patina. Because remember, quartz and agate are basically unsusceptible or extremely resistant to chemical erosion as well as mechanical erosion. Again, another aspect we talked about in the So Much More Than Agates video. So these agates can sit on the surface for a very long time, and other than developing that patina, they remain unchanged. You may be asking yourself, or maybe you want to ask me, why is it that the larger agates seem to have a rougher surface, again, the potato look, whereas the smaller agates, not as much. In fact, your really small agates, which I don't really have any that are super small here, but the smaller agates tend to be much smoother. Well, in fact, let's look at this large one. So this one that I mentioned earlier that I cut into and polished. If you look around the outer edge, there we go. You see how far into the agate the fractures go? They almost look like dendrites, but don't be fooled. Those are not the dendrite patterns we're referring to when we talk about the patterns in an agate. But those are just micro fractures. They go in, I would say, about 1/4 of an inch. Because remember, these larger stones, they only move when the river's really roaring, okay? It takes a lot of energy to move the bigger rocks. And so there's a lot more banging that goes on if the river is moving that size of gravel around. Whereas these smaller ones, it takes much less energy. And so these rub against each other with a lot less fury, if that makes sense. And that's another reason why they tend to retain much of their original form of the vesicle or limb cast that they formed in, the smaller ones retain those imprints and such much better, and they stay a lot smoother. Just for the reason that there's not as much violent energy required to move them around as there is for these big ones. Hope that makes sense. Another interesting feature of agates goes back to their formation. Let me take a minute here and mention the two main ways that agates are formed. We believe that most, if not all of them, originated in the Yellowstone Park area in relation to the volcanoes that existed prior to the Yellowstone eruption. There were many big volcanoes in that area, stratovolcanoes, maybe even comparable to Mount Fuji. So a long history of petrified forests. I believe they say there are some 27 petrified forests that have been found, one on top of another, in the Beartooth Range and surrounding areas. So these agates form in two main ways. One is in what we call limb casts, where these trees were buried and then rotted away, leaving cavities in the ignimbrites and pyroclastic flow deposits, similar to Pompeii. We've all heard of Pompeii, where they found these amazing casts of human bodies. The bodies were gone and there were hollow cavities, and someone had the idea, let's fill these with plaster and then remove the pumice and other material from around them. And so Pompeii is famous to this day because of those casts. Well, agate would go into these, if you can imagine this one here, this is definitely part of a limb cast. So this is probably a portion of the outside of a big log. So there was a cavity in the ignimbrite in the shape of a log. And if you can imagine this continuing around, forming a circle, kind of like that. And then of course it shattered and broke and came tumbling down the river. And this is just a portion of it. But you find a lot of agates that are like this. Here's another one that is most likely a limb cast. So the outside, of course, has been hammered by the river, but it's still basically in the shape of a portion of a log. So that, and then the insides can be this smooth agate, or they can be filled with quartz as well. Another way that agates form, and probably more commonly so, are in vesicles and cavities in volcanic rock. Here's an example in miniature. This is a vesicular basalt collected in the Beartooth Mountains. But you can see in this case, every one of the vesicles is a little geode. I'm not sure if they're showing in the video. I'll do a close-up of this to insert here. So here I'm trying to show it to you close up. This beautiful example of vesicular basalt with agate-lined vesicles. But in this case, I hope you can appreciate the sparkles inside each of these little geodes. They're actually agate geodes with very small quartz crystals. This is a piece of similar basalt found in the Yellowstone. Probably came, by the looks of it, it probably came from the same area. You can see up close the little agates. In this case, they're not quite geodes, but the vesicles are filled with agate. But of course, there are basalts that have very large vesicles. And this is an example of such a basalt. This is from Mexico. This is not from around here, but I wanted to show how rough the inside of these vesicles can be. If you stick your finger in there, you're likely to get cut. And I mention that because if you look at a lot of agates, such as these, some of them are smooth. They're very rarely smooth. It's not like finding a piece of quartz rounded in the river. That's a perfectly smooth rock. Agates are very rarely so. And the reason is because they have remnants of whatever vesicles they formed in. So there'll be these indentations in your agates that reflect whatever it is they formed in. If they formed in the basalt, or if they formed in another cavity, they'll retain the original form of those cavities. This relatively translucent agate still retains many of the features from the inside of the pocket where it formed. And you want to look at these when you find them, even the plain agates. Pay attention to these indentations, because sometimes they will actually be the imprints of crystals. They'll form in a cavity. This isn't the best example, but here's a cavity lined with calcite crystals. Okay, so if you can imagine, this isn't a very good cavity, but you get the idea. So that becomes filled with agate. Later, through the process of erosion, of course, the calcite grinds away and washes off pretty easy, and you end up with the reflection of these crystals, or the imprint of these crystals in your agate. So those are really cool. So those are two, this basalt and this calcite cavity, those are two ways in which the agates obtain their outside appearance, which could be quite interesting. Okay, so where does the silica come from that lines either the cavities left by the wood that rotted away or the vesicles in the volcanic basalts? Well, remember that these volcanoes, along with the lava and so forth that came out, they extruded massive amounts of ash. Of course, ash erodes pretty quickly and water flows through it. And groundwater, very slowly, obviously, can transport silica. So this transported silica makes its way into the vesicles. Like, this was probably just a huge vesicle. You can see it has imprints there, pretty much all the way around it. And then it got lined with some agate and with actually quite large quartz crystals, you can see right there. So that quartz gets deposited in all the available spaces as the groundwater percolates through. I want to conclude by sharing my thoughts on cutting and polishing of agates. I think it's a lot of fun, honestly, and I've done a few, such as the one I'm showing here. But there are a lot of agates that, especially the really big ones. I knew a gentleman in Billings who had a I believe it was a 62-pound agate. And the first thing we asked him when we saw it is, why haven't you cut that? You know, and he says, well, think about it. Everybody that comes in here and sees my beautiful 62-pound agate marvels at what might be inside. But then he said, if I cut it, and it's just blah inside, it's not interesting, or it's fractured or whatever, then all of a sudden I have kind of a junk rock to throw out in the garden. But if I keep it in here and let people wonder what's inside, it's much more intriguing and much more fascinating. And that's how I feel about these bigger ones. I know these are dark. These are dark agates. Light goes through them, but not. Here's a nice example of the conchoidal fracture, by the way, that I mentioned earlier. It breaks looking like a shell. But anyway, so these are dark agates. They're big. They're fascinating. This could be a $10,000 rock right here with an amazing dendrite pattern. or it might be blah. And honestly, I'm kind of tempted to just leave them the way they are, since I'm not in the jewelry business. And I like the idea of people saying, wow, those are nice big agates, and they might be really cool inside. And I'm like, well, yeah, they might be. Isn't that exciting to imagine? Smaller agates, that are more common, especially the dark, if you can find smaller dark agates, yeah, cut them all day long. But honestly, if you find a giant one, I'd leave it uncut. That's just my personal take. There's another type of agate called Montana treasure agate, I believe they're called. I don't know if this is one. Again, it looks like this formed in a vesicle because you could see the imprints. But look how colorful it is. And it could very well just be a jasper with some agate in it. And this is one that I'm like, I'd rather not know. I think it's fun to imagine. Who knows, maybe cutting this, it might look like a condor agate inside. Those beautiful agates from Argentina. Well, the Montana treasure agates, as I've heard them called, I do not have any that I know of, but they're fascinating. They're brightly banded, brightly colored, and they're right up there with the ones from Argentina as far as I'm concerned. But they're really rare, or more rare. And I always wonder if this might be one. You can spray it so you can see it wet. Yeah, it's such a colorful piece. Special thanks to Art W, who found this for me. He gave this to me several years ago. Well, that about does it. That's my take on Montana agates in the Yellowstone River. I should say in and around the Yellowstone River, because again, the agates are found far and wide because they've been eroding out of there for a very, very long time. God bless you guys as always. Please like, share, and subscribe if you haven't, and by all means, watch the rest of the series on the other rocks found in the Yellowstone. I think you'll find it interesting.